Hello viewers, in today's class we are going to discuss another problem from integral inequalities. So in this lecture we have an important integral inequality to be proved. So here we have to prove that the value of this integral lies between pi by 6 and pi by 3. Right? So here we have to prove that pi by 6 is less than or equal to the integral from pi by 6 to pi by 2 sine x dx is less than or equal to pi by 3. So whenever we have to prove these kind of integral inequalities, we usually make use of one important result from definite integrals. And the result says that if we have a function, say f of x, which is defined in some interval a comma b, right? And this function f of x is continuous in this interval, then the value of this function f of x, that is the integral from a to b, f of x dx, it lies between m times a minus b, and this is less than or equal to capital M times a minus b, right? So this is the integral inequality which is to be used to prove this problem, right? So here the value of this integral, that is a to b f of x dx, it lies between these two numbers, and here this small m is the global minimum of the function f of x, right? So this small m is the absolute minimum value of this function f of x in this interval, and similarly this capital M is the global maximum of f of x in the given interval a comma b. So here in this problem we are given f of x. F of x is our function sine x. The lower limit a is pi by 6. The upper limit b is pi by 2, and the value of this integral, let us denote this integral, that is pi by 6 to pi by 2 sine x dx by I, right? So we have to show that the value of this integral, that is I, it lies between pi by 6 and pi by 3. So what we have to do, we have to find the value of small m and capital M for this function f of x, that is sine x, in the interval pi by 6 to pi by 2. So to find out the value of small m and capital M, what we have to do, let us investigate this function f of x, that is sine x, right? And let us find out the derivative of fx. So f prime of x is cos x, the derivative of sine x is cos x, right? And we can see that cos x is always a positive quantity in this interval, right? So cosine x is positive in the first quadrant, and in this case our x, it belongs to this interval, that is pi by 6 to pi by 2, and this interval, it lies in the first quadrant, right? And in the first quadrant cosine x is positive, so cos x is positive for all values of x belonging to this interval. So the derivative is always greater than 0, or the derivative is positive, right? Because cosine x is positive, right? So if the function has the derivative greater than 0, it implies that the function f of x is an increasing function, right? So we have concluded that this function sine x is an increasing function for all values of x belonging to this interval. So once we have shown that this function is an increasing function in this interval, it implies that this value, that is pi by 6, gives us the value of small m, right? So pi by 6 gives us the global minimum or the absolute minimum value of sine x in this interval, and because the function is increasing, right? And pi by 2 gives us the value of capital M because the function is increasing function, right? So m is given by f of pi by 6. Then f of pi by 6 can be obtained from this relation by taking x is equal to pi by 6. So here we have sine pi by 6. Sine pi by 6 is sine 30, that is equal to half, right? And capital M is given by pi by 2, so f of pi by 2. So this is sine pi by 2, so this is equal to 1, right? So the value of small m is half and the value of capital M is 1. So this is the absolute minimum value of this function sine x in this interval, and 1 is the absolute maximum of sine x in this interval. So let us substitute all these values in this inequality. So now we can also obtain the value of a minus b. So a minus b is pi by 2 minus pi by 6, that is equal to the LCM is 6, and here we have 2 3s are 6, 3 pi minus pi, that is 2 pi by 6, that is equal to pi by 3, right? So now let us substitute all these values in this inequality. So m is half, so we have half, and a minus b is pi by 3, and then less than or equal to this integral, and a to b fx dx is our this integral, which is denoted by I. So we can write it here I, and then we have capital M, that is 1, and then we have a minus b, that is pi by 3. So now this is pi over 6, 2 3s are 6, less than or equal to I, that is less than or equal to pi by 3. And this is our desired inequality, right? So viewers, this is how by making use of this important result from definite integrals, we can prove these kind of inequalities.